Hello all, today in this video I am going to work with the with Adagrad optimizer. Already with the same code we have worked with some different optimizer, and in this code we are going to work with Adagrad optimizer. So it is a continuation of the previous video only. Initially we are importing the libraries which we are needed, then we are loading our data set. This data set is heart disease detection data set which we downloaded from Kaggle. It is having nearly 14 entries. Among that, the first 13 entries we will be using as the x variable, and the last entry, that is the target entry, we will be using as the y variable. Then we are getting the info of the data set. It has every integers, everything are integers except the float. I said 14 entries, but it is having 14 entries only, 0 to 13. Then we are just describing our data set. Then we are checking whether our data set is having any null values. Since if it is having any null values, means we have to work with some pre-processing functions. Then we are just getting the heat map of the data set. So this is the heat map of the data set. Then we are declaring the x variable and the y variable. As I said previously, x variable is having only the has dropped the target variable, and apart from that everything comes within the x variable. Y variable has only the target variable. Based on this x and y, and with the test size of 0.2, that is 20% for testing and remaining 80% for training, and also with the use of train test split function, we are determining variables like x train, x test, y train, and y test. And here we are using the use of the standard scalar to convert vectors for the x train and x test variable. Then we are getting the shape of the data set. Here this shape we will be using in the layer composition of the ANN. So the every ANN here we have used will have nearly once first initial sequential layer followed by 3 dense layer. Among that, the first 2 dense layer will take the output dimension as 11. All the dense layer will have the kernel initializer as uniform. The first 2 dense layer will have the activation as a ReLU, and the third will have a sigmoid. You can change as per the use also. The input dimension is 13, since it is our data set is having nearly 13 entries. That is the x train variable. Then we are just compiling or classifier by using the first we are using the Adam optimizer, and we are also here we are giving the loss as binary grass entropy and metrics as accuracy. Then we have used the early stopping function. Here we are going to monitor the validation loss for every 10 approaches. So only we have given the patients as 10. So if you want to monitor the loss for every some other approach, for example 5 means you can give the patients as 5. And also now, apart from validation loss, you can also choose some other parameters like accuracy, validation, accuracy loss, etc. Then we are fitting our model by using the train parameters, validation data, and approaches we have used for 50, and we are calling the callbacks for early stopping. So it does have worked for nearly 50 approaches. Here the callbacks is not working, and we have got the accuracy of 92%. Then we are defining a plot for a confusion matrix plot, and based on that we are creating the confusion matrix for every optimizer. Previously we have worked with Adam, now we are going to work with SGD. Every layer composition and all is same, only the thing varying is the SGD. Here the early stopping function will make its action, and since the approaches will stop within 15 approaches itself, and then we are getting the accuracy as 48, and the confusion matrix is also plotted. Then after that we are plotting the RMS optimizer. Here the same only, but the optimizer values only varying rmsprop. And here the early stopping is not working for, and since it's working nearly for 50 approaches and we have got an accuracy of 90%, the confusion matrix is also plotted. Then the ADA delta optimizer is also declared. Here also it is not having much, not big variation, only the optimizer will change. We have to give us adadelta. So here also the cross callbacks is not working, and we are having an accuracy till 50 approaches, and we have got 64% accuracy. Then the normalized confusion matrix is also done. Then finally this here we are going to work with ada boost optimizer. The sequential layer contributions are same only. The only difference you can notice is the optimizer as Adagrad. Here the early stopping is working, and still, and so the accuracy or the approaches has stopped till 11 approaches, and we have got an accuracy of 48. And here we are displaying the confusion matrix, and finally we are making a conclusion comparison within all the optimizers. From that, even previously also we got the Adam optimizer as the best, but now we are we now also we are getting the Adam things validation of it accuracy as best. So as of now, uh, we have worked with Adam, HGD, rmsprop, adadelta, and grad. Among that, Adam optimizer is showing better results in both accuracy and loss. In the next video, we will be working with some other optimizers. And if you are interested in knowing some other demo video, means kindly let us know in the demo comment box. Thank you.